Hi guys, I'm Govardhan HM and you're watching Observe. Welcome to Hydrogen Part 2. So in this video we'll be learning about the preparation of hydrogen and the use of hydrogen, which is very important. So the first method is the laboratory method. For this method we need to take up the apparatus. The apparatus needed are a conical flask, a 2-hole rubber stopper, a thistle funnel, a delivery tube, a downward displacement chamber, and a collection chamber. So as we take up our apparatus, we need to take up our reactants. So the reactants needed for this chemical reaction is the zinc granules and the hydrochloric acid. After taking both of these, we need to follow the procedure, which is very important. So the procedure is, first we need to take the zinc granules in a clean conical flask, and we should cover it with a 2-hole rubber stopper. In the first hole we should introduce a thistle funnel, and in the second hole we should introduce a delivery tube. The delivery tube is connected to the downward displacement chamber filled with water, and above the downward displacement chamber there is a collection chamber to collect all the hydrogen we obtain. So now comes the magical time, that is the reaction time. So as we have taken zinc granules in a clean conical flask, drop wise we add the hydrochloric acid. So when zinc reacts with hydrochloric acid, it forms zinc chloride and hydrogen gas is liberated. And when this hydrogen gas is liberated, we are already intelligent, so we have added a delivery tube. All the hydrogen gas will go through the delivery tube, and then of course it will go into downward displacement chamber. As hydrogen is very light in weight, it goes and it gets collected in the collection chamber. So the second method is preparation of hydrogen by electrolysis. So question, what is electrolysis? Well, the answer is electrolysis is a process in which we decompose or break compounds into ions by passing electric current. So here we'll take up a special compound, that is water, and we dissociate that into hydrogen and oxygen by passing electric current. So this is how it is done. So first we take a thistle funnel which is connected to a delivery tube, and the delivery tube connects two arm limbs, and these two arm limbs are connected to a platinum rod which is connected to a source of current, maybe AC or DC, which is alternating current and direct current. So drop wise we add our compound water through the thistle funnel, so it is dissociated into hydrogen and oxygen. So if we compare the volume of hydrogen and oxygen, we get it in the ratio of 2:1. So the third method is the preparation of hydrogen by displacement reactions. So a question, what is displacement reactions? So displacement reaction is a type of reaction in which an element, more reactive one, displaces a weaker element, which has low reactive capacity from a compound, is known as displacement reaction. So using this method, this is very crazy. This is how we prepare hydrogen. So there you go. So the fourth method of preparation of hydrogen. What was that? Yeah, the Bosch process. This is also known as the commercial method of preparation of hydrogen because we can prepare a lot amount of hydrogen with it. So first what we do is we take up coke, which is a byproduct of carbon, and with the water in the form of steam at 1000 degrees Celsius, carbon monoxide and water, that is water gas, is formed, and this is an endothermic reaction, and it is done in a special converter chamber. And we take up this water gas, and with excess steam again at 450 degrees Celsius, we use iron oxide or chromium oxide as catalyst to obtain carbon dioxide and hydrogen. So this is an exothermic reaction, and we need only hydrogen, right? That's the main part we require. So we should remove these carbon monoxide and carbon dioxide, which are now waste. So what we do is we take up the mixture and make it to flow under a high pressure of water. What happens is the lightweight hydrogen will go up, and carbon dioxide is removed, and we use a chemical to remove carbon monoxide, that is ammonical cuprous sulfate solution. So we use this lengthy named chemical to remove carbon monoxide. So later we obtain our hydrogen. So